Hey, 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 we're back again. Welcome to today's lesson. We're working on sequences again, and today we're going to narrow down the type of sequence we talk about. It looks like the word arithmetic, and it is the word arithmetic. However, in this context, it's pronounced arithmetic. See the stresses on that third syllable right there. Arithmetic sequences. All right, I'm gone. Bye. Okay, so arithmetic sequences, you just add to get the next term. So what's the next term in this first sequence? How about 12? I think you can all agree we're adding 2 in this pattern right here. I think you can all agree we're adding 3 in this second pattern, right? 3, 6, 9, 12, 15. What are we doing in the third pattern? To get from 20 to 17 to 14, we are subtracting 3. Yes, or using the correct mathematical terms, we are adding a -3. So what is the definition of an arithmetic sequence? An arithmetic sequences are sequences where let me use the cursor on the screen here, where a common difference, D, is added to get each term. So these numbers over here on the top left, they're actually D. D equals 2, D equals 3, and D equals -3. That's it. There is really no fancy math about this. It's just the number that you're adding or subtracting. However, mathematically, we're always adding, all right, even if we're adding a negative number. Now, let's just take this last pattern here and let's come up with a formula from this. To get the first term in the sequence, it's just 20. To get the second term in the sequence, I know it's 17, but how do we get 17? We can take 20 minus 3, and humor me, this is 20 minus 3 times 1, and then we get 17. Why did I write that times 1? You'll see. To get the third term in the sequence, we're going to take 20 minus 3 again, but how many times must we subtract 3 to get to 14? We have to subtract it twice. That's 20 minus 6, and that's what gives us the 14. To get the fourth term, I hope you're starting to see a pattern here. We're going to do 20 minus 3 times 3 and get 11. Oh, by the way, if I go back up to the top, this would be 20 minus 3 times 0, which would give me 20. All right, I don't know if you recognize this pattern right here. I'm going to use a red pen. To get the first term, we subtract it 0 times. To get the second term, we subtract the common difference once. To get the third term, we subtract the common difference twice. To get the fourth term, we subtract the common difference 3 times. What if I wanted to find the 10th term? I would take 20, and I would subtract the common difference 9 times. Why? Because you always subtract 1 less than the term you're looking for. Why? It's because I'm giving you a gift of the first term to begin with. Think about this. If I give you the first term, let's just say it's 5, and I want to get to the 6th term. 1, 2, 3, 4, 5, 6. There's the 6th term right there. How many times must I add that value? I only have to add it 1, 2, 3, 4, 5 times. I hope this is not confusing, but you're just adding it 1 less. Why? Because I'm giving you the first term as a gift to begin with. So everybody find A sub n, which is the arithmetic sequence formula. I take the first term, which is A sub 1, that's the gift, plus D, the common difference. And how many times do I have to add the common difference? 1 less than the term I'm looking for. So what's 1 less than n? N minus 1. Okay. All right, so let's define the letters here. N is the term number that you're looking for. D is the common difference. And A sub 1 is the first term. There it is. All right, so let's move right along with our examples here because we are ready to roll. Pause this, rewind it, play this over again, but this is what we're going to be using for the rest of this lesson. Let's read the directions because we only have to answer what's being asked. Given the following arithmetic sequences, find the common difference and the next 3 terms. So here, how do I get from 35 to 32 to 29 to 26? If I Get it right. I'm subtracting 3. I'm subtracting 3. I'm subtracting 3. So D equals -3. Don't overthink this. Just subtract 3 more times. So 23, then 20, then 17. That's it. That's all I have to do. How do I get from -3 to -23? Well, I'm going to subtract 20. -23 to -43, subtract 20. By the way, if the sequence is arithmetic, that difference will be constant. So D equals -20. So then to find the next three terms, just keep subtracting 20. So -83, -103, -123. These are the two things that are being asked for, and that's what we found. Whenever in doubt, to find D, let me go back up here. You can always subtract any term in the sequence by the previous term. So, suppose you're looking at number 4 and you're a little confused. What's D here? Is it +10? Is it -10? I can always take any term and subtract it by the previous term to it. So what's -40 minus a -30? That's a -4 plus 30. So D equals -10 here. So I'm subtracting 10. So then my next three terms are -70, -80, -90. Never guess what D is. You can always find that out. All right, skipping to the next set of examples. All right, more directions here. Use the given arithmetic formula to find the first three terms and the specific term named in the problem. Okay, so let's see here. They're just giving me the formula. There it is. I don't have to do anything. Find the first three terms. That's the last night's homework. First three terms are a sub 1, a sub 2, and a sub 3. So that's -11 plus 7 times blank. -11 plus 7 times blank. -11 plus 7 times blank. Now notice it doesn't say n minus 1 here. It just says n. So don't overthink this. Just plugging into that formula. So, and if this is n and this is n, it's whatever that number is I plug in. So 1, 1, 2, 2, 3, 3. So -11 plus 7 is -4. -11 plus 14 is 3. -11 plus 21 is 10. And then it says, find the given term, a sub 34. That's just -11 plus 7 times blank. To be honest, there's no n minus 1 here. They're just giving me an arithmetic formula is just one where you're at. And this is an arithmetic formula. So I'm just going to plug in 34 for this. All right, I don't want anyone to make a mistake here. Do I do negative, here, let me use the cursor. Do I do -11 plus 7 first? Or do I do 7 times 34 first? 7 times 34, Mr. Cody. That's right, 7 times 34. Don't make that mistake. So it's -11 plus 238. And that gives me a final answer of 227. I'm only going to do one example in this section because I think you could figure it out. Find the first three terms and then the term that's given. Just plug in the values. Okay. Number 11 and 12 and so on. Given the following terms, determine the equation of the arithmetic sequence. Okay, so the equation is just a sub n equals a1 plus d times n minus 1. All right, so we got to figure out three things here. Got to find the first term. The first term, this problem is 4. Done. What's d? We get from 4 to 8 to 12 to 16. We're adding 4. And we don't know. It just says determine an equation. So it's just a sub n equals the first term 4 plus d, which is also 4, times n minus 1. Guess what? You're done. Some textbooks and literature tell you to distribute and simplify. I'm not going to make you do that. Let me erase those rainbows. Okay, you could leave it just like that. All right, second one, we need to know two things. First term is 9. Oop, I went to black, sorry. And what's d here? How do I get from 9 to 7 to 5 to 3? Yes, you're subtracting 2. So the formula for the equation is 9, which is the first term, minus 2, which is d, times n minus 1. That's it, done with that. That's all that I must do. You will also do the same through 13 through 16. Same thing. All right, now let's get to 17 through 20. Write the rule for the arithmetic sequence with the following properties, then find the nth term. All right, so this is basically putting the past two types of problems together here. So they're giving me the first term and d. So the first thing I'm going to do is I am going to, you know what, I'm going to write this. This is 1 right here, and then this is 2. So step 1, write the formula. So a sub n equals first term, -1, plus d, which is -10. So I can just write -10, sorry. -10 times n minus 1. Next step, step 2, find a sub 25 because I'm replacing n with 25. So it's going to be -1 minus 10 times, it's 25 minus 1 technically, but what is 25 minus 1? It's 24. I remember you multiply first, so then that's -1 minus 240, and I get -241. It's exactly what I do right there. I'll do number 19 with you. Step 1, write the formula. A sub n equals first term, -7, plus 3 times n minus 1. There is step number 1 done. Let me circle it up here as well. Step number 2 says n equals 17, so I'm going to find a sub 17. So I'm going to do -7 plus 3 times 17 minus 1, which is 16. So that's -7 plus what? 16 times 3, which is 48. All right, -7 plus 4, 48 minus 7 basically is just 41. And there we go. All right. Oh man, a fraction. What should you do with this one here? All right, so step 1, I'll do it with you because I know you're curious. A sub n equals first term 2 plus 1/2 times n minus 1. There is my first term. First step. Step 2, n equals 8. So let's find a sub 8. That's going to equal 2 plus 1/2 times 8 minus 1, which is 7. And I'm going to write 7 over 1 here. So remember, when you multiply fractions, it's top times top, bottom times bottom. So 1 times 7 is 7. 2 times 1 is 2. And so if I want to turn this, this is 2 over 1 right here. If I want to get a common denominator, I could multiply by 2 on the bottom and 2 on the top. And if I do that, I end up with 4 over 2 plus 7 over 2, which is 11 over 2. And done. Last set of examples. I'll do 2 of these. The given number is a term in the sequence. Which term is it? So it says 124 is the blank term of this sequence. In other words, how many terms, if I get rid of this ... how many terms must I go out until I get to 124? So if I write the arithmetic formula here, a sub n equals the first term. Do I know the first term? It's -2. Plus, do I know what d is? How do I get from -2 to 5 and from 5 to 12? I do believe we're adding 7 here, right? So I'll do plus 7. So I know the first term and I know d. What I don't know is n. How many terms will it take to get out to 124? So we're taking the arithmetic sequence formula and we're solving for n. All right, but wait, we know one other variable here. I know what a sub n is. What is the nth term? It says 124 is the nth term, so it's actually 124 equals -2 plus 7 times n minus 1. It's not a sub 124, it's just 124. 124 is that term. So now it's just a matter of working out the algebra here. Let me use a black pen just to change it up. So plus 2 and plus 2. So 126 equals 7 times n minus 1. I'm at a crossroads. I could either distribute the 7. I could distribute the 7 to both of these terms, or watch this. I could divide both sides by 7 right now. And I could do 126 divided by 7. And it does go into 7 evenly. It's actually 18 times. Equals n minus 1. And then now it's gravy. Just add 1 to both sides. And n equals 19. That means that 124 is the 19th term of this sequence. If I kept the sequence going 19 times, kept going it out, or setting, continuing it out 19 times, that's what I'd get to. All right, so let's give ourselves some space here. Let's do one with subtraction. We'll do 24 and we'll call it a lesson here. So negative 297. So what I like to do is I always like to write the formula first. A sub n equals a sub 1 plus d times n minus 1. We're solving for n again. Negative 297 is this nth term. So negative 297 goes right here. The first term is the 87. How do I get from 87 to 83? 83 to 79. 79. Aren't I subtracting 4? So minus 4 times n minus 1. So now I am going to subtract 87 from both sides. And if I subtract 87 from both sides, I'm going to get negative 384 equals negative 4 times n minus 1. Once again, I could distribute the negative 4, but I'd rather divide by negative 4. Get rid of it. So the negatives here cancel. And just to write it over here, I'm left with 96 equals n minus 1. Add 1 both sides, and I get n equals 97. So this would be the 97th term of this sequence. All right, hopefully I did one of each type of problem for you guys. Please ask questions if you have them. Bye, everybody.